Welcome to ClickMyProject.com. Our project title is Space Penalized Decision Forest for the Imbalanced Data Class. Our project abstract is the class imbalance poses a critical challenge in binary classification problem. Particularly when we are rare but signification to the events or the unrepresenting in the training set. While to the traditional machine learning model and modern deep learning techniques struggle with such of imbalanced dataset, further decision tree and random forest combined with the data sampling strategies have shown to the effectiveness and then tabular dataset. However, to the undersampling and oversampling approach often to the introduce to the complexity and risk loss of the variable information. These paper introduced to the space penalty destination algorithm. Destination algorithm is one of the machine learning algorithm. We can move on to that our novel method for the space penalized decision forest algorithm. A novel classifier tailored for the imbalanced binary classification. Our proposed method integrated to the penalty on the surface to the volume ratio of the decision set within decision tree construction. So the address classes imbalance without additionally sampling. The proposed approach enhancing the predictive performance and generalized to the leveraging ensembles learning techniques such as the bagging and then adaptive boosting method. We evaluate the metrics on the 20 benchmark tabular datasets, spinning device sample size and imbalance ratio, and then superiority overall several state of arts and data level and algorithm level methods. Furthermore, simulate the dataset with a visual interpretable structure showcase to the model generalization capacity. Statistical signification test the valid the robust of that our approach. Finally, we can provide to the Python package imbalance-spdf, that is one of the package method offering to the accessible and implementation for the particular this research process. Our project flowchart is first we have start with the Anaconda Navigator spider tool for the Python backend process. After that, the front end we are move on to the HTML CSS for the Flask process wise. So first we can start with that dataset. So dataset for that we have taken to the 20 benchmark dataset, means we can move on to that chance prediction dataset we have taken. That is the mostly imbalanced data for the part. So that dataset we have taken. After that, we are applying to the data pre-processing. Data pre-processing means data cleaning, and then after to the data normalization method. So data cleaning means missing value checking and label encoding, and then unnecessary row and column will be removed. So these are the stepwise we have clean to the data. After that, we can move on to that smooth method. So smooth method is a imbalance technique, but we can move on to the space penalized decision forest algorithm. So that algorithm wise we have move on to that imbalanced data, we have move on to the balanced data. After that, we are applying to the classification algorithm for the decision tree, random forest, SPM, and then 4 machine learning algorithm we can apply it, and then we have predict to the performance analysis, and then we can move on to that Flask application for the user login, register and upload your data, and then visualize to the process smooth ways how to get the performance analysis and the visualization part. So once we can log out to the process, again we have the login and then enter to that your upload data set is the imbalanced data set, means we have changed to the balanced data set ways. Our project execution, first we have taken to the input data set, that is the data selection, data pre-processing and splitting. So first we have read to the data. After that, we are checking to the data pre-processing. These are the missing values will be there. We can remove it on to that part. So after that, we can move on to the EDA plot, data splitting. So the 80% of training and 20% of testing part. So next one, we can move on to the classification part. We are using to the smooth algorithm, we can apply it, and decision tree, random forest. So these are the algorithms, and then we have find out to that performance analysis and EDA plots. So these are that. So next we can move on to that the web page. So first we can register. So we can register to the CMP, password is a CMP and register. So register is successfully. We can move on to that login page. So the CMP and password is a CMP. So we can choose into the data. So we can choose to the data set, any data we have taken. So we have choose the data and then upload and analysis to the model, and it's take to the time that part. After that the visualization the part.